Every time I wanted to quickly store some text on the internet so that I can reuse that text anytime later from any internet connected computer, I use this website called protectedtext.com. It's like a very simple website to save your text securely on the internet and protect it with a password. Suppose you want to save your college assignment on the internet so that you never lose it and you should be able to retrieve it anytime you want and from anywhere. One option available is you can upload your assignment into Google Drive and save it there. Or you can also use a more simple way. You can copy all the assignment text and go to protectedtext.com/assignment-teja or whatever your name is, or any string you wish you can put after the slash there. And then you can create your site if that link is vacant and paste all the assignment text and click save. Now you can choose a password to protect your text. And that's it. It's that simple. Now you can retrieve your saved text from anywhere by going to the link you created. You just need to enter the password and then you will be able to see this text in the text box. I've been using this website for at least 2 years now, and never did I actually wonder how secure this website is. Until recently, I decided to test how the website works and if it can be exploited or if it has any vulnerabilities. So I started my work. First, I imagined this website to work like this. User visits the link that he already created and he will be prompted to enter the password. Once the user enters the password and clicks decrypt, the password is sent to the server and compared with the password hash, which is already stored on the database. And if the password is valid, the content or the text saved in that particular link will be retrieved from the database and it will be sent to the client where it is displayed in that text area. But I was absolutely wrong, because this is what I noticed. When I go to any link I created, I will be prompted to enter the password. At this point, I turned off my Wi-Fi so that there is no internet connection to my computer. Now if I enter the password, intuitively thinking the saved text should not be displayed since the password I entered cannot be validated because there is no internet connection. But surprisingly, even though there is no internet connection to my computer, as soon as I entered the password, the text saved in that link is revealed. Now this clearly shows that the password I entered is never sent to the server for validation. Everything that's happening is on the client side. Then I confirmed this by reading the message on the website homepage. It clearly says that the passwords will not be sent or saved on the server and only the encrypted text will be saved on the server. Which means no one except you can decrypt the text that you saved in any particular link. Only the one with the password of that particular link will be able to decrypt the text. This immediately got me thinking, well, if almost everything is happening on the client side, more precisely on the web browser which I have full control of, can't I just exploit it? And I really believe that there must be some way in which this website is vulnerable because it's doing all the processing on the client side. So I immediately opened the client-side source code of the website and I found some external JavaScript files. And one of them said main.js file for protectedtext.com. So obviously this is the main file which includes the algorithm of this site. So I immediately opened this link to read the JavaScript code and it was a pure heaven because almost every line of the code has a comment explaining what that particular line of code is for. They intentionally did this because they want the users to read the code themselves and confirm that the information they store on this website is completely safe. And the fact about the passwords not being sent to the server is actually true. So I read the code and I will brief you how it works. Suppose let's say you created a link on protectedtext.com and saved some text in that link. When you click on save, you will be asked to choose a password to protect your text. Once you enter your password, the first thing the code does is it calculates the SHA 512 hash value of the text. A hash is a one-way function, which means once you convert any string into a hash using a hashing algorithm, you cannot get back the plain text form of the string from this hash value. Alright, next thing the code does is it encrypts the text with AES algorithm using the password that you chose while creating the website or the link. So the encrypted text can only be decrypted with the password that you chose. It then sends the hash value of the text and the encrypted text to the server. On the database of protectedtext.com, the site URL, the hash value and the encrypted text is saved. Now later when you visit that same link that you created, you'll get a response from the server with 5 parameters, which are site URL, encrypted content, is new, current DB version, and expected DB version. Site URL is nothing but the name of your link, that is the string proceeding after protectedtext.com. Encrypted content is the encrypted version of the text that is saved on that particular link. You cannot understand this encrypted text because you need to decrypt it first with a key. In this case, the password that you chose when you created the link is the key. Is new is a parameter which tells if the link that you are trying to open is a new site or an already existing site. In this case, it's going to be false since the site is already created and it's not new. We will talk about current DB version and expected DB version later. Alright, so once these 5 parameters are received from the server, the next thing that JavaScript does is to decrypt the encrypted content. It can only be done with the correct password of the site. So once you enter the correct password, the encrypted text will be decrypted with the same AES algorithm and the original form of the text will be shown in the text area. The next thing the code does is it calculates a hash of the decrypted content and stores it in the variable named init hash content. Once again, remember that hash is a one-way function. Now, if you modify the text on the side and click on the save button to save the changes, this is what happens. The hash value of the modified text is calculated and saved in the variable new hash content. The values init hash content, new hash content, and the encrypted form of the modified text is sent to the server. The server then compares the init hash content with the already existing hash value of the database. If both match, it means the user has the required privileges to commit changes to the site. And then the hash value will be replaced with the new hash content, and the encrypted form of the modified text will be saved on the database. But if the hash values do not match, it simply means that the user doesn't have required privileges to do any changes on the site. So all the changes will be ignored. So if you notice here, the value init hash content is somewhat like a password because it is used to check the authenticity of the user before making changes to the site, like modifying its content or changing its password. That being said, can you think of any loophole in the website right now? Well, at this point, I was totally believing that this website has a security loophole. Because look, since the init hash content is the parameter that is used to check the authenticity of the user, if we know this value, that means we can pretty much modify the contents of any particular website or any particular link and also change the password of that particular site. So, is there any way we can get to know the init hash content? Well, it's nothing but the hash of the initial text on this site. So, if we know the text that is saved on a particular website or a particular link on protectedtext.com, we can easily calculate its hash value with the SHA 512 algorithm, which is open source. And hence we can modify the site and also change its password without having to know the original password of the site. Makes sense, right? So I immediately tried to test this. I created a site named Testing Web and set the password for the site as test password. I then saved the text sample in this site and saved it. Now my objective is to modify the content of this site and also change the password of this site without using the actual password of the site. And of course, provided that I already know the text that is saved on this site, which I already know it is nothing but sample. Alright, first I need to calculate the hash of the initial text, that is sample. So I calculated the hash value for the same. Now if I want to modify the text from sample to vulnerable on that site, I need to also calculate the changed hash content or its new hash content actually. So I calculated the hash value of the text vulnerable. And then I encrypted the changed text vulnerable with a password that is not same as the actual password of the site. I did this so as to be able to change the password for this site without knowing the original password, of course. I used the password OMG to encrypt this modified text because I was hoping I could change the password from test password to OMG by doing this. I then clicked the save button and intercepted the request message that is being sent to the server with Burp Suite. Here I can find all the parameters that I was talking about. So I changed the init hash content parameter with the hash value of the text sample that I computed manually. And then I changed the new hash content to the hash value of the text vulnerable, and I changed the encrypted content parameter with the encrypted value of the modified text that I manually encrypted using the password OMG. So now when I forward this request, I was expecting that the content of the site will get modified from sample to vulnerable, and the password of the site will be changed to OMG. It didn't work. The password is not changed and the text is also not modified on this site, which means I was not able to change the content and the password of the site provided that I know the text that is saved on this site. I wondered why. I got back to the JavaScript code and then I noticed something. Earlier I told you that we will be talking about two parameters later, namely current DB version and expected DB version. In the part of the code where the init hash content value is calculated, there is an if-else statement which I didn't pay attention to. It says that if db version equal to 1, it calculates the hash value with the SHA-512, and the parameters required for this function are just content for hash, which is the text saved on the site. So in this case, clearly the vulnerability that we thought exists actually exists. It's true that the vulnerability exists. And if db version equal to 2, it again calculates the hash value of the initial text with SHA-512. But here the parameters required for this hash function also includes password for hash, which is the actual password of the site. Now in this case, the vulnerability that we thought exists is not valid anymore because the hash function also requires the password, and I didn't think that the hash function requires a password to calculate the hash. I thought it just requires the content that is to be hashed. So we just cannot compute the value init hash content without knowing the password of the site. So yeah, this is why we failed in our experiment. So I already told you that the parameter db version is sent from the server, which means we as clients or users cannot decide if the parameter db version will be 1 or 2. It is actually decided by the server. Even though if we want the parameter to be 1, it's not in our hands. It's completely decided by the server. The first version of the hash function clearly has a loophole. I think that is why they added a if-else statement there, and they upgraded the hash function to a more secure version. And no matter what, the db version is always going to be 2 because it is sent from the server and they know that the first version of the hash function is vulnerable, and hence sending db version as 1 will make the vulnerable hash function to be executed, which results in the security being compromised, because if db version is sent as 1, the vulnerable hash function is executed, and that means anyone who knows what text is existing on a particular link can change the text on that link, and they can also change the password of that link without actually knowing the actual password of that particular link or site. So I think initially they were using this vulnerable hash function, but later they might have noticed that it is vulnerable, or someone might have reported that this hash function is vulnerable. So I think that's why they upgraded to a more secure hash function where they included the password as one of the parameter. So yeah, we failed in finding a security loophole in this website. And yeah, I know this outcome is upsetting, but I hope you learned something from this video, and I hope it inculcates your knowledge in cryptography. I mean, it must have helped in some way, guys, some or the other way, right? Alright, so thanks for watching this video. Comment down below what you think about it. Leave a like if you like this video, and subscribe for more awesome videos if you did not yet subscribe. And once you subscribe, don't forget to activate the bell icon so that you receive instant updates from me. Alright, I'll meet you in the next video. Until then, thanks for watching. Cheers.